In this lesson 1.6, we'll go over linear equations in one variable. Clicking on Start, we'll get to the objectives. This will feature absolute value equations, solve formula for specific variables, solve linear equations in one variable, and do some applications. To give some background, as we look at what I've written here, now is this an equation? No, this is a mathematical or algebraic expression. Now to make it an equation, we often think we put an equal sign in there, and then over on this side, you might say 8x plus 12. And you look at that, and this is no longer an expression. It looks like an equation because of the equal sign. But are all things that look like this with an equal sign true equations? And that's where we're going here. There are basically three types of things that have equal signs in them. Now, if we had something like this, 5x plus 2 equals 5x plus 2, we know what's on the left is exactly the same as what's on the right. This is referred to as an identity, and whatever value you put for x on this side is the same for this side. So the solution of this type of equation, an identity, is all real numbers. And we often just use the funny shaped R there to indicate the symbol for all real numbers. Now, if we were to change this somewhat and make this 2 over there, let's say a 4, now no matter what value I put for x, and if you subtract it out, 5x from this side, 5x, you'd get 2 equals 4. This is never going to be true. Well, in this case, there is no solution. And we call this type of thing, even though there's an equal sign there, a contradiction. And then there's finally the kind that you are perhaps most familiar with, where eventually you get that x equals 3. You've gone through a series of algebraic steps solving the equation, and you get that x has this singular value. Well, this type of equation, the more typical one, is called the conditional. That is, if x is 3, then it is true. All right, for background, again, pause, read this over. And again, pause. This gives you the detail, and they're using example 1 to feature this. All right, take a moment. So here is the standard form of your general equation. Where a is not a 0, and this is an equation to the first degree because the variable is to the first power. We don't write the 1. Every variable, every number is to the first degree. We just don't write it. If it's higher than the first degree, we then write it. And reading the rest of this, the protocol for solving equations is what you do to one side, you do to the other side. It's no longer the same equation, but it's still equivalent. In example 2, they're giving us 5 little items to work on. Let's work on one, let's say 2A here. We'll go to the whiteboard. We've checked that we copied it properly. And they're starting us off with a rather challenging one. So the rule is get rid of parentheses, grouping symbols. So this will become, as we distribute, 3x minus 6 plus 7x equals 1. And then distributing this is a negative 2x. And then the 2's here cancel out, and this become a negative 1. So we add up our x's on this side, grouping like terms. This gives us 10x minus 6. And here the 1's cancel out. This equals a negative 2. And we want to keep, 2x I should say, all the x's on one side. So I'm going to add 2 x's here. Leaves me with a 0. Add 2 x's there gives me 12x. I'm going to subtract, well, I'm going to add a 6 to this side. Now divide both sides by 12. I get x equals 1/2. Now notice in doing an equation, you want to try to keep your equal signs lined up. And what you did to one side, you did to the other. And eventually there are some shortcuts and there may be other ways to do this. Let's take a look at what the book has. And raising this up a little. For the first one, x equals 1/2. And item B, and we'll go to the whiteboard. Again, we want to get rid of parentheses, so 3x minus 7, distribute 3x minus 6. Now notice if you subtract out your 3x from both sides, you end up with a negative 7 equals a negative 6. This is not true. So for letter B, there is no solution. This is a contradiction. And checking it out, I didn't quite do it the way they're doing it, but again, they get 0 equals 1, which is not true. It is a contradiction. In item C, we get an equation in which there are fractions. So the protocol for this is to get rid of the fractions by multiplying each of these terms by the lowest common denominator. And this is usually done like so. And our lowest common denominator, can you see it? It's going to be a 6. So by multiplying each of these terms by a 6, it'll make our denominators a 1. So here the 6's cancel out. This is just going to be y. Here the 2 cancels out with a 1. 2 cancels out gives me a 3. So in a sense, I'm going to multiply this by the 3 that's left. This gives me, this is a plus here, 6y minus 3. Here the 3 will cancel out with the 6, and I'll get a 1. And this then becomes, in a sense, a 2, and this is 2y plus 2. I'm going to group my like terms. I get 7y minus 3 equals 2y plus 2. Now, one of the shortcuts that we have in algebra is to take a term from one side, move it to the other. It just changes its sign. So positive 2y on this side becomes a negative 2y, which will give me a 5y. A positive 3 on negative 3 on this side, positive 3 on this side gives me a 5. And I get y equals 1 when I divide both sides by 5. And then looking at this, check it out here, y equals 1. Now as we look at item D, we see this is one term, one term, one term. Each term has 2 decimal places. Well, I can get rid of those decimal places by multiplying everything here by 100, which is just moving the decimal place over 2 places in each term, which is what I've copied. I wanted you to see that as we go to the whiteboard, and I'll get rid of this. It makes it a little easier to calculate getting rid of decimals. But what you do to one term, you must do to all of them. And we get here 25x distributing minus 75 plus 8 equals 15x. Now I'm going to bring this 15x over to this side as a negative 15. This becomes then 10x. I'm going to add these together or do the subtraction and then bring that over to this side. Now that's going to be, I'll pause and work it out. As we see, this gives me a negative 67 on this side. Just transpose it, becomes a positive 67. Divide both sides by 10. I get x equals 6.7. All right, let's go back. And there we see it. And for letter E, we'll just use what's there because I think it's straightforward. As you note, once you clear parentheses and group like terms, when you do the solution, you end up with 0 equals 0. Is this a true statement? Yes. So this was in fact an identity. 5x plus 12 equals 5x plus 12. And for an identity, the solution is all real numbers. Let me show you that here. And there it is, and using that thickened R for all real numbers. Going on, as we look at this, pause, read it over. Here we're dealing with what are called absolute value equations. And it looks like this. Now, there is a protocol to solve it. And I'll go over that as we do it. Now, remember one thing is if you had an absolute value of something that was equal to a negative value, this cannot be true because there are no absolute values that end up being negative. So keep that in mind as we see the examples they'll show us shortly. And if you're taking notes, this is example 3. We'll go to the whiteboard. Now, what's the protocol? Now, for all of these, here's the protocol. You take away the absolute value signs, and that will be one possible solution. Or take away the absolute signs, and this could have been a negative value. Remember, because this value in here could have been a positive value, or it could have been a negative value. And again, this without the absolute signs, having it equal a negative, that's the protocol. That's okay. It's just that when it has the absolute value signs, you can't have this on the right be a negative. So we're just going to solve this. 3x transpose the negative 2 makes that a 3. Divide by 3, x equals 1. Again, transpose this. This is now going to be a positive 2, so this is a 1. 3x equals 1. X equals 1/3. And let's check this out to see how we are doing. And x equals 1, x equals 1/3. In item B, we have two sets of absolute value. And let's go to the whiteboard. And again, what you want to have here is a strategy for doing these. So item 1, as we think of it, just remove the absolute signs. X minus 4 equals 2x plus 1. Or x minus 4 equals, now we have to make each of these values a negative 2x, a negative 1. So that's the protocol for dealing with absolute values. So solving this, and I want to keep my x's positive, so I'll move this x over to this side, just becomes an x, this over to this side, negative 5. So there's one answer. Now here, I'm going to move my x's to this side to keep them positive. This becomes 3x. Move this over, becomes a positive 4. This would be 3. X equals 1. All right, let's check it out. And I'll move it down so we can see it. And there it is, x equals negative 5. X equals 1. Now, looking at example C here, notice the first thing you would do, 6x minus 7, the absolute value of this, is to isolate the absolute value. So we're going to take this positive 5, transpose it to the other side, where it becomes a negative 5 plus 3 will give us a negative 2. And again, my reminder from an earlier topic here, we said when we see something like this, you cannot have an absolute value equal a negative. So for this, there is no solution. And here they're indicating that. Now, from our study of sets, if you recall, when there are no elements we put a circle with a slash through it. This is the symbol for what is called an empty set. There is no solution. So you get the full measure. I'm going to pause it here and read this over. Going on, in example 4, we're going to deal with solving equations for a variable and not actually do a specific example, but just to isolate a variable that we're looking for. So I'll raise it up a little bit. And we want to do the first one. And we'll do it together. So P equals 2 lengths plus 2 widths, and we want to solve for the letter W. So we're going to take the 2L, move it to the other side, where it just changes its sign. And then to isolate the W, we divide both sides by 2. And we get W then equals this. Now, when you're putting this into the software, be sure you use a capital letter P and a lowercase letter L. They started you off with a rather easy one, now a more challenging one. This is the compound interest formula. And as we look at it, we want to solve for P. So basically, we're just going to divide both sides by this, which is 1 plus R over M raised to the mt power so here this just cancels out, and I can erase that actually, make it a little easier. And there's our answer. Now if we wanted this in the numerator, remember we could write it this way, P equals A, and now bring this up and then just use that as a negative exponent. Okay, so either way would be satisfactory. Let's take a look at what the book does. And there we see it, this way and that way. All right, in example C here, or item C, we'll go to the whiteboard. They want us to solve it for H. So what we would do is just take this, like we did, bring it over to this side, and then divide everything by this so that the H is isolated. But I'm going to modify this. Not that I'm the author or anything, but I think it's more challenging if we solve it for pi. Okay. Well, in solving it for pi now, we have to isolate the pi. We do so by factoring the pi out of these two terms. And I don't want to put pi there again. This is just going to be 2r squared. And then 2rh. So we have taken the pi out of each term, And now, how do we find what pi is? Well, divide both sides by this. And then this all cancels out, and we get pi equals that. Okay, so something a little different. And let's go back, clear this up, and look at what we have here. And there's what we said too. We're going to transpose the 2 pi r squared and then divide by 2 pi h, and there's our answer. Going on now to a few applications, word problems. They're featuring two formula, distance formula, distance equals rate times time, and simple interest. Interest equals principal times the rate times the time. But let's look at this first one. Example 5. The distance from Shreveport, Louisiana to Austin, Texas by one route is 325 miles. If Kevin made the trip in 5.5 hours, what was his average speed? So we're using the distance formula. Rate times time equals distance. So we know our distance was 325. Our time was 5.5 hours. What we don't know is the rate. So we're going to divide both sides by 5.5. Put that in your calculator and you get 59.1 miles per hour. And going back to our text, we see it right there. So this was sort of an easy one. And in example 6, we're going to have an interest problem. Again, our formula is interest equals principal times the rate times the time. So I've read it over, but pause, read it over and fill it in. Well, the rate is what we don't know, but we know this is for 1/2 of a year, and the interest for that would be $600. But they want to know what would be the rate for a year. So we're going to multiply both sides here by our lowest common denominator, 2. So this then becomes 1,200 equals 1,500 times the rate, which is what they're showing here. Divide both sides by 1,500. We get the rate is 0.8, which is really good, 80%. All right, for our last example, take a few moments to read what I have here, and then we'll raise it up a little. And in analyzing this, they're using two variables that they sort of snuck in on us. But let's just look at this here. How much solution do you need altogether at the end? And the answer is 500. Now, how can we divide 500 into two portions? Now, they're doing this using two variables. We're just going to use one. Well, we're going to say part of this is x, which is not known of this 500. And the other part is going to be the 500 minus x. Now they come up with this below, but think of it this way. And if you add these two together, you just get 500. The x's cancel out. But you divided this into two parts. So let's say that part of this is going to be the 10%, and part of this is going to be the 20%. So let's say 10% of x, that would be this portion, plus 20%, put a 0 in there, of this portion is going to equal, you want to have a 14% later, which will be 14% of 500. And I'm going to take this away so it doesn't confuse us. And there is your equation. So we'll go to the whiteboard shortly and work it out. And I've done the work here. First, what I did is get rid of the decimals that we mentioned earlier. Always a good thing. Multiplied through. Combine like terms. I got negative 10x equals negative 3,000. X is 3,000. And if you recall our little diagram here, if this were 500, and x was part of it, and then it was 500 minus x, if x is now 300, what will y be? The amount of 20%. Well, that will be 200. Now let's check this out and go back here. And there is the x is 300. And you subtract the 300 from the 500, and you get 200 for the 20%. Okay, well, this winds us up. It was some challenging material, expanding a little bit differently into areas of equations, and hopefully helpful.